Okay, let's start. Today's topic is on baby editing. You know that over the last decade, we've been dreaming whether we may produce our next generation with what we call high quality person. I'm not so sure what do we mean by high quality, but some people say, wow, perhaps this is eugenesis, 優生學, you know. Baby develop and run faster, could listen to music perfectly, we call it perfect pitch. I don't know about this, there are only two kinds of men, either with gray hair like me or without hair. Okay, I'm not so sure how we can do this, but most people like to create people with high IQ. I'm not so sure how this could be eventually implemented. Perhaps we could never do so. But it was like a dream for some people. But today I would like to expand a little bit more than just from a baby. Also from from a wider scope, starting from human cloning or animal cloning. Because the technology now is available, whether we use it or not is a different matter. Or the name of what we call gene therapy or gene editing. And of course, we would go over this Cas9 technology a little bit, because that actually revolutionized the whole concept of gene editing. Now, right now the problem is baby editing. Now, all these issues actually have ethical concerns. Okay, so the original title is very long, baby editing and its associated ethical issues. Because we're talking about manipulating embryo, controlling reproduction, or even controlling the genes. Now, our genes are supposed to be given, right? Given to us by our parents. So you would imagine, okay, that perhaps we are all created by God. So are we playing God in order to change our own genes? And now the technique is available, okay? The technique is available. The technique is called gene editing by using CRISPR. CRISPR has a very long name. Cluster regularly interspace short palindromic repeats CRISPR and associated proteins. The protein, the enzyme is called Cas9. There are different similar technologies available, but I'm not going to explain all the details of the technical details. However, because of the availability of this technology can be used in different animals, but yet to human, okay? But what happened last December actually shocked the world, because a professor or doctor in mainland announced that he actually edited a baby. And he even announced, oh, I'm so proud of it, you know. Initially, people thought, oh, that would be a great idea because of the dream of doing baby editing. But if you look deeper and think in great details, I mean, for the ethical concerns, then you will realize that there are many ethical issues of editing babies, so we'll go through this one by one. We start from the first part, human cloning. You know, that came from the technology, you know, Dolly the sheep, right? You have heard about Dolly the sheep. Exactly 1997, or even earlier, in Scotland, they cloned Dolly the sheep. So people jumped up and said, oh, perhaps we can clone human as well. So there was some crazy idea came out from the Dolly the sheep, and then, oh, perhaps we can clone human. Do you think human could be cloned, like making photocopy? Raise your hand, you think that you can do that. Yes or no? Yes. But actually, a clone is only a twin, right? Now you have to consider one very important parameter. One very important parameter is time. All biological organisms are able to reproduce, and then they have to grow, right? So if I have cloned myself, starting from scratch from a baby, and that baby would have the same genetic materials of myself. So it's actually what we call as a twin, what we call as a twin, me, right? Having said that, it takes time for the baby. That's it. Identical twin, if they start develop at the same time. But if I need to clone myself, then you have to realize that I have to wait for the baby to grow up, right? So that's the major problem. To me, human cloning is impossible. Now, cloning, we start from fertilization. You know, I spend much more time when I teach this content in a GE class, but in a life science class, I don't think I need to spend too much time. But just to remind you that we all need to form a zygote. Our genetic materials are from our mother, which is in the egg, and also from our father, which is from the sperm. So this is zygote, indicating that there will be two sets of chromosomes, right? Two ends. One set or one end haploid from the sperm, and then another haploid actually is from the egg. It's a haploid called nucleus, right? And then after fertilization, the fertilized egg will divide. 2 cells, 4 cells, 8 cells, 16, 32, until it forms a blastula. Now this is the blastula stage with the different cells committed to form different body parts, right? Now we can remove this inner cell mass. A basic question that when we consider reproduction or abortion is that when does life begin? 生命幾時開始呢? So raise your hand if you think that, okay, 2-cell stage is the beginning. Raise your hand. No? Too early.
It's practically alive already.
You think it's alive already, right?
But it's not.
But it's not a full body yet.
Yeah.
Okay? Biologists will consider this in a more complicated way, I would say. But for layman, I would say, okay, that's life begins, right? So abortion, we must say no, right? But according to local law, actually, we have like a requirement for two doctors to sign the document, and the embryos should not be older than 3 months. You see, in practical terms, the difficulty for abortion is that I should not spend too much time on that because you are going to discuss all this later in coming weeks, okay? But one point to note is that you have to realize that a woman or a girl would never realize that she was pregnant until perhaps what? The first period delayed, right? And then delay and delay. And then you realize that, oh, okay, the eggs perhaps fertilized. Otherwise, you will see the internal breeding come out with the unfertilized eggs, right? So the time would be what? At least 2 weeks to 4 weeks, or even 2 months to confirm whether the eggs fertilized. So you say, okay, that's the definition of life, but in reality, it's very difficult to confirm, right? Okay, so, but that's not the major part I would like to bring into. I would like to bring into is that at the different stages, the cells actually, then they form a zygote, 2 cells, or even a multiple cell embryo, and to the blastocyst, or 5 days for human, around 200 cells. And then you can see this, the blastocyst, because the body parts are going to begin, right? But before that, these cells, 1 cell, 2 cell, or 4 cell, or 8 cells, they are still what we call totipotent. They are totipotent, meaning that either one of them or any one of them, if you take it out, it would become an embryo. With that in your mind, there are different cell types we have to manipulate. Cells from early embryos, 1 to 3 days, usually they're totipotent. And then later on, after they commit into different body parts, they will become pluripotent. But then at the end, if we take away some fetal cells or cord cells or blood cord cells, or adult stem cells, they become multipotent. Right now, many of the experiments are going on with this, what we call, like cord cells. They are multipotent, okay? But they are not pluripotent. They are not totipotent. Now, human cloning or animal cloning refer to this kind of concepts and involved in, like, for example, the first monkey clone is known as tetra. Why it's called tetra? Because you can see the fertilized eggs and then develop into 4-cell and 8-cell stage, and then they did embryo splitting, dividing these 1, 2, 3, 4, 5, 6, 7, 8 cells, each one individually put into another egg. Another egg with its original pole nucleus removed. Okay? So that one would become an embryo. That is how exactly they created this cloned monkey known as tetra, because they started from 4 cells. And then they isolate this, and only one survived. Only one survived, okay? And that became this cloned monkey. But since then, we have not heard any further steps on doing monkey cloning. Same thing is true with the same concept. Theoretically, okay, this is actually the slides are from this company known as Advanced Cell Technology. They aim at producing animal cloning technology, and they aim at doing those, we call that in the future, the therapeutic cloning method. What they can do is that from an egg, they can make a pass-through pipette, and then with a pipette pillar, put it out, very sharp needle form, and then punch in to remove any whole nucleus or cells from an egg. We call this step enucleation. So the recipient oocyte here, you may remove the genetic materials from an egg. And then later on, from any egg, you may put it in any cells. In this case, in a nucleate egg, you may do what we call cell transfer. The cell containing the genetic material from the donor, okay, the donor, is placed inside this layer known as suna pellucida through this membrane, and then inside. And then what you need to do is to apply an electrical pulse, just like electrical shock, to stimulate the egg. I always look at it, I thought, oh, just like those geniuses, wow, you can see the sparkling of electricity from the outer space, just like the ghost message. I'm just kidding, but you need something to stimulate and give the message to an egg. They tell, okay, now you can develop, and that they can develop into an embryo. And that's the technology, we call it cell transfer. Okay, we'll talk about this concept later on. So with this concept, these are crazy people thinking of perhaps one day we would remove from any adult from a cell. You remember this is a somatic cell, 體細胞. So it has the original 2 sets of chromosomes, 2N. And then from this, you may grow in a cell culture, right? You may grow a lot of cells. And then these cells, you can remove the nucleus and then put it in any egg doing the nuclear transfer. Just like I just mentioned, with the original genetic materials removed. And then that particular egg from this donor would give birth, not really give birth, but fertilize into an embryo of human. The genetic materials mainly from this person A. And then step 3, you need a lot of foster mother. Now this, why I have to show to you this very old slide, because there are many different concepts involved, involving the manipulation of eggs, involving the manipulation of nucleus, involving the manipulation or production of babies using foster mother. And all these steps have ethical concerns or issues. Like for example, I don't think right now, I think in the US, in some states they could do that, or in South America. People in the United States, they usually go to Mexico or Middle or South America countries to do that, because there are foster mothers available over there. And there are many donors like to donate eggs right now for gay couples. For gay couples, if they want to have their own baby to form a family, they may rely on donor to donate eggs. All right? But of course, that would not involve this, we call it somatic cell nuclear transfer technology. And that technology actually, in theory, yes, so you're right, in theory, you could produce this baby. But you would imagine how many foster mothers do we need? According to the experiments done with the tetra, the monkey, the cloned monkey, they were so lucky that 4 made embryos, 1 survived, right? That's why it's called tetra. But according to the experience from Dolly the sheep, they manipulated 200 something eggs, 200 something, and only 1 Dolly the sheep came out. Okay? Of course, I cannot compare, you know, different animals. But theoretically, we probably need at least 10, or even if not 10, 20s, or even more foster mother, right? Of course, that came out 20 years ago. We can see the date, 2002. Not many people still mention it. Actually, nothing happened after that. Nothing happened after that. Because we have to say no to human cloning. Because after 1997, with the Dolly the sheep technology announced, and also with that, you know, I would call it devil project announced, countries around the world already say no to human cloning. Number 1 is unethical, you know. Number 2 is that the technology is immature. We don't know exactly how many foster mothers are needed. Okay? And then we do not know the outcome because we have never experimented any other primates. We usually use primates, right? But nowadays, if you want to do research involving primates, it's not that easy. Okay? As I said before, the tetra was made only 1 time with a report. And that is it. No one ever tried it again. And of course, I keep using this as an explanation of saying no to human cloning. Is it justified? Is it justified? And then finally, it's also a very important concept that life could not be duplicated. I mean, I could duplicate myself, but I would foresee that the duplicated embryo of mine would never develop into myself like this. I remember watching a movie. That man cloned himself in 4 persons. 1 is a playboy to fool around. Another one is actually a workaholic, so doing all the job, making all the money. And then the 3rd one was like a family man. Okay, look after the babies and the family, a very good family man. Okay, and that 4 is the original man, actually felt very lost in life, would not know what to do. So you would imagine that if I have, or in that character in the movie, 4 individuals with the same genes, if they do different things, actually these are 4 different individuals, right? So you cannot say, okay, you have cloned it. And of course, the timeline concern, you could never have done so. I mean, you can create one that is myself, and then the other 3 clones would be much younger than I do. So the reality is that at home, my daughters would yell at that little boy. Would my daughter consider that little boy me or their brothers? Right? So then, and we have a long list of ethical concern. The identity of that cloned person, because it's not 100% me. So at the end, actually, one key point is that even if my genetic material has been duplicated, and then like these are all in my somatic cells, right? And then duplicated, and then develop into different embryos, and then they all develop into different individuals. They only have the same genetic materials. To make up a person like myself, it requires more than just my genetic materials, right? It needs a lot to do. If you want to play piano, you have to practice. If you want to develop a healthy person, you have to rely on the food intake, right? So we have other issues. In other words, we only have our genetic materials to contribute, I would say, 1/3 of myself or your good self. Right? The other characters came out from, I don't know, you may joke with me, okay, that perhaps with horoscope. Okay, if that person cloned developed into different birthday, then we have different consequences due to different suspicious claims. But in reality, we also have to consider training and food and environmental factors to develop a person as such to be cloned. So in other words, we could never really clone anyone. Now, because of the debate over thought leadership and also the concerns around the world of doing human cloning, including Hong Kong. Hong Kong actually in 1998 started to develop this or debate over this human reproductive technology bill. Now this bill is actually under review. The review postponed in LegCo. Okay, I'm not so sure whether this bill will come back next term. I mean, starting in next week. The coming LegCo will be from 2019 to 2020, right? They're doing a review. Why do they need to do a review? Because of the technology now is available to edit a baby. Now, this bill was created before CRISPR, okay? Based on human cloning technology. And then the bill, in order to stop human cloning. Number one, the bill prohibits replace the nucleus of an embryo with nucleus of another cell. So in other words, is to stop what? NSCT, the somatic cell technology. So the technology, the photo I just showed to you, to do enucleation and then cell transfer, the technology is banned or prohibited. Number two, to ban or to prohibit clone an embryo. All right? And then number three, trading of embryo. Trading of embryo, in other words, you are not allowed to become a foster mother. So in Hong Kong, it's prohibited. Okay? If you really want to do so, I understand that many tycoons, they did that overseas. All right? But that would be covered in the further discussion in the coming weeks. Now, why the technology is important? Because the technology of this NSCT, or cell transfer, would aim at doing what we call gene editing. The gene editing technology actually relies on a therapeutic gene to be cloned, and then the gene to be put into the patient, right? But how this could be achieved? the recent Shaw Prize actually gave to those scientists that discover genetic recombination. But in order to do manipulation, the techniques actually rely on this vector known as retrovirus. So retrovirus is a virus that will bring in any DNA into the target cell or target organ. In practice, the cell-based delivery is actually cloning the therapeutic gene you want and put it into a virus, usually it's a retrovirus or lentivirus. We can buy any lentivirus kit in the lab. And then the lentivirus will bring the gene into the target cells. So the target cells could be, as we mentioned, the embryonic stem cell, so the ES cells, or the adult stem cells, as the cells come out. And then after that, we may grow and grow and regrow many of these repaired cells. So these cells will be repaired and put back into the organ, target organ. Okay. So that is the technology right now available. And perhaps, actually they are doing with CRISPR. So gene editing now is replaced by CRISPR because of the problem of retrovirus. The retrovirus is a virus. Most people concerned with the virus. What's the difference between CRISPR and virus?
CRISPR is bacterial based.
Pardon me?
CRISPR is bacterial based.
The louder piece?
CRISPR is bacterial based.
Oh, okay, it's bacterial based, but you only need to purify the DNA, right? Same thing is true here. You use the lentivirus, but then the DNA is inserted in. But the major difference, of course, is site-directed. CRISPR is that you have the DNA sequence guiding the target DNA to go in a specific location. But then for virus, these insertions are random. Actually, there were cases that the first so-called gene therapy failed because the patient died. Because the technology is not mature. We are not so sure how these lentivirus or where they insert the therapeutic gene into the target genome. Okay, that's the major stumbling block. Number two is, of course, if you involve in virus, then everybody feel more scary, right? A bacteria may be better, but actually in the application of CRISPR, they never use bacteria. They just put the DNA in. And then another DNA to express the Cas9 enzyme. 2 DNA in. Okay, so that's the details of the technology. But coming back to this discussion, there are many related laws. I told you a law in Hong Kong. It's very simple statements highlighting the technology to be banned. No foster mother, no nuclear transfer, and so on. But how about related laws in different countries? So in many countries, the major problem is how are we going to manipulate the cells? So what kind of cells could be manipulated? So in United Kingdom, human cloning is allowed for only what we call therapeutic use under the license system, and then the human embryos only up to 14 days. Now that comes back to my first slide. When the slide begins, okay, according to them, 14 days is the limit. If it's after 14 days, if you don't do anything, that would become a human. So if it's only 14 days before the major organs develop, we may still manipulate the what? The multi or totipotent cells. Usually they do that with those 38 cell stage. Okay, but this is only by law. But in China, actually, cloning human is not agreed, allowed, supported, or accepted. Very clear law. So I don't know why Dr. Kerr could get his permit. Okay, we were very shocked because under Chinese law from the Ministry of Health, totally banned. In other countries, of course, like in the US, they say stem cell funding stopped. Okay, after the time when Obama became president, and then later on they lifted the restriction on federal funding for research. In other words, private funding is still allowed. You know, America is a rather free country, so the nation's top administration could stop the funding for research, but they could not really stop the private funding. Okay, therefore, there are companies like the Advanced Cell Technology that would like to do the manipulation, but the manipulation later on become debatable. And then scientists say the research will lead to medical breakthrough, but many religious groups are opposing it. So, you know, there's a constant debate what they can do or what they cannot do. And then in Washington, there is a National Right to Life Committee, and then they actually don't really have time to think about how much they could support stem cell research. You know, we all know that stem cell could be a good thing, I mean the research, but involving the manipulation of human stem cell is a very different matter and sensitive issue. As I said before, the gene therapy failed because that was the experiment done in 1999. But then involving rival vector, and then the patient died. And since then, no other techniques are available until last year, started with CRISPR. Now, but I think before that, or until we go into further discussion, if it works, are we prepared? If the technology is available, do you think baby editing should be allowed? It's kind of like eugenics, right? 優生學. Do you think that should be allowed? Okay? And again, if I come back to those legal advices, oh, if it's involved government money, no. Because that would be very difficult to confirm who could benefit and who could not, right? You cannot say that, okay, you live in public housing, you are not allowed to do so. All right, so that would be a very sensitive issue. So, and then second, what kind of trials that you would like to improve? Most people would say in Hong Kong, you know that in Hong Kong, short-sight seeing, myopia, is a genetic disease. Most people would say, okay, perhaps if we could identify all these genes. I have a colleague in PolyU, they have identified 6 to 10 genes relating to myopia. They want to try it in different animal models. You see, the stumbling block is that we could only manipulate animals. So how are they going to try different experiments on humans if we could not allow any stem cell research, right? So it's like a hand-egg puzzle on its own. All right. So we'll have some more discussion whether we would prepare to make a Superman. But we realized that with the human cloning technology and coming back to stem cell possibility, that is to say that all these pluripotent cells could be developed into different organs and eventually put them back into our body for organ transplant. So therefore, for stem cell research on its own, some countries are quite supportive, including China. You'll be surprised to learn that many Chinese scientists from Shanghai or Beijing and in different provinces, they've been actively involved in this kind of research. And then for other countries like in Italy, Portugal, Germany, and half of the EU, they are not supportive. Okay, in the US, as I mentioned, it's already divided.